Alright, I guess my name is Subhav. I'm a junior in computer engineering, and I'm going to be showing you guys a basic introduction to Git and doing a little bit of demos, and you guys can join along too. First of all, it's sort of weird that we're presenting a tool, right? Because we use a lot of cornerstone tools in this project, and the projects in this group. We use Python, we use Python libraries, but we don't present those. We just look at code and see how to use them. But why on earth would you want to present about Git, right? So there are a couple of reasons. One is that you guys are here and you can ask me questions, and that's really useful to you. The other reason is that knowing why Git exists and how it works is sort of necessary to using it. And if you know how it works, then using it's going to be really easy, and it's also going to make it really easy for you to go online and look at tutorials and commands and see how to use them properly. So at the most basic level, Git is a type of backup. It's not backup in the same sense that you normally think of backup, but when our project consists of code, and a lot of code, it's a good idea to keep it as safe as we possibly can. So that's one of the reasons we use Git. But it's not really my computer crashed and I need to recover all of this code sort of backup. It's my code was broken, so I need to go back and look at a previous version of what I had so that I can recover from that. And so Git's not especially useful for backing up files in the case of emergencies, because Dropbox and Windows backup and that sort of thing already do that really well. Git's more useful for my code is broken, or I wish I didn't get rid of that last paragraph, and now I can't recover that. Because if you're just storing your last version of whatever you had somewhere else, it's not especially useful to have that sort of backup, right? So you use Git to keep track of versions. And so the technical name for this is version control. And before we can start using it, I just like to go over some basic terminology and how it works just a little bit before we do a demo. So I think that will make it easier to get to understand what's going on. So at its most basic, version control is you have a project, or you have a folder with your project in it, and you want to copy a version of some of the stuff that's in your folder to some filing cabinet sort of thing, some place that stores all the previous versions of all of your files in your folder. And unlike something like Dropbox, you do this manually. You say, I want to copy a version of these files into what's called a repository. So there's some technical names for these actions and these objects. The folder that your project is in is called your working directory. The place where you store all of this stuff, like I said, is called a repository. That's really important, and we're going to talk about repositories a lot. And copying a version to that place is called committing it. So you take files, you commit them into this filing cabinet with all the previous versions of everything that you had, right? And you can also take stuff out too, and that's called checking stuff out of your repository into this folder where you have your project stored. I think that's pretty straightforward, right? So I'm going to do a little bit of a demo about the stuff that I just showed you. So I have a folder here called demo on my desktop with a few files in it. I can add some of the files in this directory. So the way that I would do that is git add and then the name of the file. So for example, readme.txt. Well, I can't do that yet. So the reason I can't do that yet is because I didn't create that place to put those versions of my files. So what I have to do first, and you don't have to do this for the projects in this group, but you would if you wanted to use Git on your own, is to make this folder have a repository. So if I do git init, it says it initialized an empty Git repository in blah 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 blah. And so now if I list everything, it created a new folder called .git, and that's where that repository is stored. So now if I do git commands like git add and then that readme file, it actually did something. It didn't tell me exactly what it did, and if I want to find out what it's actually doing, there's a really neat command called git status that I can type, and it will show me exactly what's going on. I don't think there's too much about this, but it's basically saying there's a new file that I added called readme, and that's something that I want to put into the repository. So the way I put that, like I said, the technical term for it is committing. So the way I would do that is git commit, and then there's nothing after that. It's just git commit. So I want to commit what I just did. And if we give it a second. So now it opened up my text editor. Is it okay if I'm using Vim, by the way? Just so this is my text editor. This is where all of this stuff, where I can edit stuff. So it's asking me for a commit message up at the top. So right up there, I'm just going to write that this is my first commit. And I'm going to save that. And so now it says that it did something. It added a file, so one insertion, and one file changed. So the way I did that was I added one file. I can also add more files. So if I want to just add all the files in this folder, I can just do store. And that should have added everything. And I can check that, again, by doing git status. And it says that I've added a bunch of new files. And so now what I'm going to do is commit that I want to add those files. So git commit again. And added more files. All right. So just to reiterate some of the commands that I used were I added file names, right? So git add, I could, file 1, file 2, file 3, or star, or just the name of the file or whatever. General like Linuxy, Unixy sort of thing. I can check the status of what Git's doing at the moment, and then I can also commit whatever I added. So so let me go back to that demo real quick, and I might want to make a change to one of the files. So let me clear that up and just list everything. So let's say I want to change the file participants. Okay. So let me open that up in my text editor, and this is a list of people who participated in the demo today. So I'm going to add myself to that. And then, so now if I want to commit that change that I just made to that file, and like Git is all about saving different versions of the things that you already have and like the changes that you make. So if I want to do that, then the way I would do it is not to say git commit. So if I do status, let's just read what it says. It says changes not staged for commit, and one of them is that I modify the file. So if I do git commit right now, it's just not doing anything, and it's telling me I have nothing to do. So what I have to do first is do git add again. So git add isn't just for adding files to your repository, it's also for adding changes to your repository, and that includes like deleting files too. So I want to git add that change that I just made by doing git add and the file name again. I apologize if you answered this. Let me do that add. So I git add the name of the file again, and now it's done something. And if I do git status, it tells me what it just did. So now I have a change to be committed, so I can git commit, and now I've committed that change, and it told me that I committed that change. So what's actually going on when you do a git add is that you're copying the files that you want to change. So if I did a git add and then I started changing stuff again, what actually is going to be committed later on is the older version when I did that git add. So git add takes a copy of a file that you have, and then git commit commits it into that filing cabinet full of old versions of your stuff, and it bundles it up into a version. And that's why it's called version control, right? So let's go back to our demo. And so like storing all of these versions isn't especially useful if we can't really do anything with it, right? So let me make a few more changes. So I have another file called to-do. I'm going to open up that file. So I have a to-do list full of stuff. Let's see. So that's something that I need to do. So now I can git add like I did before, that to-do file, and I can commit it. And so it did stuff like it did before. Right? So I've stored all of these versions of things that I have before, but I want a way to access those versions and do stuff with them. So obviously I made a really dumb typo in that file. Finish is not the name of a Git tutorial. So I want to change that. So one of the really useful things you can do in Git is compare things to the last version of whatever was there. So I can do git diff and then the name of the file. So it's the differences between the file that's there now and the last version that I committed. So git diff with that to-do file. And so it tells me a whole lot of information. The most important information is down here at the bottom, and it says that I removed this line and added this line instead. Does that make sense? So again, a couple more of the commands that we just went over were, one of them was git diff, and I'll explain the other one real quick here. So like I said, removing files is one of those actions in Git that has to be committed, which is a really great thing, because now if I remove a file, like I remove that README file, so now I no longer have it in here, but it's stored as an older version of one of my files in that repository. So one of the things that I can do is get it back, and I said the technical name for that is checking out a file. So the checkout command is used for different things. So if I want to check out a file, I have to use this -- thing right here. So, and then the name of the file, so readme.txt. And so now that added the file back. It just brought it back from the last version of whatever was there. And if you do that with a file that already exists and has been changed, it'll rewrite that file. So that's one of those things you might want to be careful about. So I think that's all pretty great, right? So I can look at the last version of the file that I've been using, and I can do stuff on my own computer. Like all of this is just happening inside of a folder in my computer and using a program called git.exe. But what's really probably one of the most useful features of Git that we use it for in our projects is being able to share stuff with other people. That's really important. So the basic idea of how you share stuff in Git is you have the repository on your computer, and the whole idea behind sharing stuff in Git is you copy that entire repository somewhere else, or you copy all of the changes in that entire repository somewhere else. So I could copy this entire repository to Eric's computer, and if he made a change, I could copy all of his repository back to reflect those changes in my computer. But obviously, if you have 20 people working on a project, this can be ridiculously hard to manage, and it's probably not the best way to do stuff. So instead, what you'd rather do is, and what we do in our projects is, we have that repository in our computer, right? But instead of copying it to other people, we just copy that entire repository online somewhere. So there are a bunch of hosting services that do this and also add a bunch of extra features. We use GitHub, but there's also like Google Code and Bitbucket, for example. So instead of copying it back and forth between each other, we just maintain this one shared copy of the entire repository somewhere and just upload and download changes to and from that place online. So what Eric can do now is download it, instead of download it from my computer, he can download it from the internet. And so can everybody else who's working on the project with us. So there are like 3 actions that just happened there that went by really quickly. One was that we could upload and download files. The other thing, and this is a little bit different, is that Eric downloaded an entire repository brand new from the internet. And so the technical term and commands for these are, what Eric did was he cloned the repository the first time, and then whenever I want to upload or download something, I can push or pull things from that shared repository online. So those are the 3 commands that are used to do stuff with other people. So now let's actually do that. So on GitHub, I've created this blank repository. So I just went up here, I said I want to add a new repository, and then it presents me with this page which says there's nothing here yet because you haven't actually uploaded anything. So I'm just going to copy and paste the stuff down here into, and maybe I should probably do it from here. I'm just going to copy and paste this stuff into my, there we go. And you don't need to worry about knowing these commands, but what it did right there is it copied and pasted, or it copied everything in my repository, so my entire repository, and put it online somewhere. So now, if you're following along, you can use this command, git clone, or rather, you can use this command, git clone, and then the URL to my repository to download it, and you can start doing stuff with it on your own computer if you want to. Is anybody actually doing this? Following along? Yeah. Just let me know when you guys are done. And feel free to ask questions too if any of the concepts don't really make sense. Are you guys good? Is anybody not done yet? Alright, cool. So now you can start doing those same commands. You can add changes to the repository, commit them, bundle them up into a commit, and then commit them. And so don't do any of the remote stuff yet, but try just messing around with some of those changes. Like there's a file named participants.txt, and so why don't you open that in your text editor. I might as well do it here too. So one of the files that I edited was participants.txt. So why don't you open that up and add your own link to it, and we'll see what happens. I might make a commit of my own too. So let me. Alright, I need some feedback, guys. Let me know when you guys are done. Good? And if I need to walk through anything again, let me know too. Alright, so has everybody created at least one commit? Yeah. Ginny? Have you created a commit on your own computer? Yeah. So have you done git commit at least once?
Yeah, I added my name to the repository.
And then you did git add and git commit.
Yeah, and push
Okay.
it.
So everybody did that? Yeah. Alright, so now I want everybody to do a git push so that, like I said before, that, and I can show it again. What that is it, right here, it uploads your changes to the place where we all store it on the internet, right? So everybody do a git push right now and see what happens. And so I got a really long error message. Did anybody else get that? So there should have been one person who didn't get it and like a bunch of people who did basically. And so I can explain what's going on and why we just got that error message. So what's happening here, there we go. So what's happening is I might have made a change in my repository right here, excuse me, and I wanted to upload that change. And so that change is reflected on the internet right now. Right? So I uploaded my entire repository to the internet. And somebody else made a different change and tried to upload that to GitHub. And what happened was there was some information in this change which is no longer reflected in that change. So what GitHub did was it said, you're losing information right now because there's information here which isn't there, or in the yellow one which isn't in the blue one, right? So it just doesn't let you do that at all. And so we need to do something different. So what we need to do is we need to download the changes from the yellow version and merge them into that purple version that we had, or that blue version that we had before rather. And then try uploading it back and see what happens. And if we upload it back again, it should work. So the commands to do that again are, we need to download the changes, so we do a git pull, and download whatever changes are on the internet right now. And then we do our git push. And that seemed to have worked for me.
I have a question. When you pull it, does it overwrite what you have changed as well?
No, not
So
quite.
like
It
if you added
combines
something,
the two.
okay.
So it tries to combine the two as best it can, and sometimes that doesn't quite work out. And we'll see if that happened at all here. But
And if you don't commit it, then it will just overwrite it.
if you don't commit it, then it will, I believe it'll download the changes but not change any of the files that you've changed.
You should always
So-
commit before you pull, right?
Yeah.
Because you commit, at least you take a snapshot.
Mhm.
So if you are not sure, always commit before you pull. That way, just in case what you change is overwritten, you can pull it back.
Or at the very least, what you can do if you're unsure about even doing that much, what you can do is do a git add, right? Because that's the step where you actually take snapshots of files and copy them, and just store them somewhere which isn't a commit yet. So if you do a git add, then you're copying those files, but you haven't yet done anything with them. So if you do that, Git might tell you you have to commit this before you can take any next steps. But at the very least, if you do a git add, you stage those changes for commits. It goes into some staging area where it stores those files and copies them, and you don't have to worry about that as much. Of course, you might have to go online and look up the commands to do things with those files that you've not put there. But at the very least, you've copied them, even if you didn't want to make a commit yet. All right. So did everybody pull and push? Yeah. Did anybody have any errors pulling?
I have a question.
Yeah.
So we both skip pull the latest version, but we are different.
Yeah, we have different. Like I don't have his name on mine, but he has both our names on him.
Okay. I mean, you might have to just do it. Did you do it like at the same time?
No?
No.
We did.
I did mine pretty early.
Okay.
Do it again.
Yeah. Try it again. It
See when I
might
pull,
be.
it says already up to date.
How about his?
Yeah.
See, it
Or
says
up
already
to
up to date.
Okay.
And
Try
then
to get status. See if you have that file changed, but you haven't yet committed it. So that's what I'm thinking the problem is.
I did something like this. Your branch is up to date. Contract files. It's participants.
So is one of those an untracked file?
I mean, it has the same file with the tilde at the end.
Would
No,
that
till
be
is
a
a
bad idea?
backup file.
Yeah,
Yeah.
so I don't need to bother about that.
You don't
That
need
has
to
to do with your text editor.
Right.
But you're sure the actual version of the file is correct?
Hmm.
That's an oddity. Like I actually don't know what's going on there then.
Can you
what
go
I
to,
think it
can you
is
go
is
to
that
your
we-
GitHub and see?
Sure. Yeah, I can do that. So here's what we had before I did anything, and now if I refresh this page, we have the README. That's just something that GitHub does automatically, and we also have all the files that are put there. And so all of this stuff will let you do stuff with it later on, but so the file that we're interested in is participants, and that's something that a bunch of people did stuff with. So the version that's actually on GitHub right now only has my name and Abhishek's name on it.
So you need to
So
You didn't push.
So,
Do you?
let me go back to that one slide, which had,
Do you push?
so is it letting you
Now
push,
it's fine.
or is it giving you an error?
You pushed?
Yeah.
Okay, can you go back to and do git pull?
Yeah.
Okay, can you go to GitHub back
Yep.
and
so
then
now if I go
reload?
back here and refresh it, now it
There
has
we go.
everybody's name on it.
Okay.
That's what we want. Did anybody else have any issues with this? Did anybody have any issues pulling? 'Cause I'm curious about that, and that can happen. Sometimes you'll have an issue when you're trying to pull something, and I don't see anybody else's names on here, so I'm curious about whether or not everybody's doing this quite right. So if you have any issues, this is a good time for us to walk through it together, right?
My SSH key got deleted by Everett said reconfigure that, so that's why I'm not up there.
Mine is network issue. I lost internet connection.
Okay.
So I need to do the all.
My git push is got rejected?
Okay, your git push got rejected. So
Yeah,
what
it's
happened when?
Can you do git pull first?
Yeah, I did. I'll try that again.
How about you?
I'm just listening.
Have you used this tool? Are you very familiar with GitHub?
Yeah, I use this all last
I'll try to get
maybe
it.
whole semester.
Okay. So did it give you an error when you were trying to
It
pull?
worked now, he's in there. now.
You're all good? Okay.
Okay, if you refresh,
So now if I refresh this page,
So push between I commit and I push.
do you push?
Yeah, so you,
Yeah, I did.
so it looks like
Oh,
there's still an
oh,
issue
right.
because you haven't.
You haven't pushed yet.
I did.
What do you push?
What did you
I
put?
modified
I think he
README
pushed. I didn't push.
Oh, read
Oh,
README.
you
He modified
the
README.
file, okay. That's fine.
If you go to history, you can also see.
oh yeah, I can see
Yeah,
it.
so this is an awesome demo.
You can go to participant.txt and see history.
I tried to modify.
Yeah, so
Okay.
I can look at the history of one file by going to history here, and it'll from the top down, it'll show the last change that was made, and then the oldest change down here, which was when I was just adding those files initially. I can also look at all of the changes that were made by going up to 10. It says how many commits were made. And so on GitHub, one of the neat things is that I can see all of the changes that were made in the entire project. And if things were recent, it's very useful to look at this and see what happened. So the reason I was asking whether or not people had issues with, give me a second. The reason I was asking whether or not people had issues with pulling is that sometimes that does happen, and so you'll be presented with something like this. So it'll tell you that the pull sort of worked, but you still need to work out some things on your own. And so you're presented with something that looks like this, and it's really, really confusing, and sometimes doesn't make sense what exactly that is. So in case this ever happens to you, I'm just going to explain it really briefly. What that is Git, two people made changes to the same file, but Git didn't know what changes to keep and how to keep them. And so in a text file where it's just people's names, Git had a pretty good idea of what to do. But sometimes it's confused with, especially with code, you don't want to just layer 2 lines of code on top of each other and try to figure out what happens. You want to actually do what you want it to do. So if people change the same thing, it will tell you what one person changed and what another person changed. And it's your responsibility to change this and then create a new commit with the new file that you just changed. So you do a git add and a git commit. So in case that ever happens to you. So I think that's it for the demo, and I hope that was helpful to you if you've never used Git before. But right now I'm going to talk a little bit about how to find things in older versions of files, apart from just using GitHub. GitHub is really neat because it lets you do all of that from a web interface. But knowing how things are related to each other in Git and how it works a little bit deeper down is really helpful in using it properly. And I'm just going to talk about the basics. So I'm going to represent a commit using a circle here. So this is our commit. And every commit gets put through some hash function which generates this gigantic mathematical number which is represented in hexadecimal, and that represents that commit. And that's how Git works. Other version control systems don't quite work that way. But if we want to create another commit after this one, say this is our last commit, and we want to create another commit after this one, what happens is we create that new commit, and it points back to the last one. So if you've taken a data structures course or like an intermediate C course, you know that this is starting to look like a linked list. And so as we keep creating more and more commits, we create a linked list starting from our most recent commit, working our way backwards. And so I can give you a little bit of an example of what's going on. So let me pull all of this stuff that's on GitHub right now. So I did a git pull down there, and it changed a bunch of things. Participants and README both got changed. And let me do a git log. So this works its way from the top down and shows me the most recent commit all the way up at the top and some of the older commits down at the bottom. And you can see that every single commit has this gigantic number associated with it. But that's actually extremely useful, and we can do some really neat things with those numbers. Maybe one of the most basic things you can do is git diff. So again, diff compares the version that you have in your folder right now with an older version of the file. So let me go back to that. So one of these commits started with 4b3f, right? And that modified participants.txt, or readme.txt has been modified since then. Let's use readme. So it starts 4b3f 2, and so on. So I'm going to git diff with 4b3f. I hope that was right. And so this shows me all of the changes that have been made since then. And so you can go to GitHub and work your way through the menus and try to figure out how to do this there. But if you know how to use git log, then you know how to, and you know the way that Git stores this information, then it's really useful to be able to do this. And so this shows me all of the changes that have been made since that commit. So the other really neat thing about Git is that it lets you structure your workflow a little bit better. So that whole topic is called branches, and all they are so sometimes we have commits which represent, or which mean something, and commits which mean some other thing. So one of the commits might be the place that we're working on right now. So that's our development commit. And so the way we reference it is we create what's called a branch, and all that is a pointer to that node on that linked list. So it's a pointer to that commit. So we keep track of where these commits are by creating branches. And if we create a new commit on the right of that, so add another node to this linked list, what happens is this pointer to development, because we're on it right now, it changes along with that. So there might be another branch, which is, say, the live version of the website, but we don't want to touch that branch right now. So the one that we use is master. So the master branch is also just the default branch in Git. And we use that to represent where the website is. So we've made a bunch of developmental changes since that last master commit. But keeping track of it is really important because it's telling, for one, it's telling the production, the live server, don't use any of the code that's been written after this. And it also lets us go back and see what the code is actually there. And if we wanted to change it from that point, we could too. So let's say our development on the website is done at the moment, and we want to merge this master branch into where the development branch is right now. So if you do, the command for it is git merge. I'm not going to show it in this demo, but if you do a git merge with master and development, then it will move this branch over to where the development branch is pointing. So when we're ready to upgrade what the public has access to, for example, on a website, then, or the version of our code that the public has access to, for example, we just move master over. And so if you extend this idea, as you might imagine, this is a data structure, and branch probably means that things are branching off of each other. So if you extend this, you get something crazy that with a bunch of extra features. And I very much encourage you to look at how this works if you're curious. I can explain it right now, but I think it's a little bit out of the scope of this presentation, unless you guys really want me to. Is there a lot of interest in this?
I mean, we could probably go over branching a little bit more in detail.
Okay.
I mean, try to keep it on base level, but
Sure. Yeah.
something that's going to be important for, especially the web team.
Yeah.
And we'll be running into that.
Sure thing. So let's say we just have our development branch. There's no master branch or live version of our website or anything. Just a development branch and a linked list of commits going all the way back to the beginning of the project. So if I do a git branch, the command to create a new branch is git branch, and so that creates a feature branch. And so we've switched from our development branch to this new feature branch, and the command to do that is checkout if you want to know about that. And so now that I'm on the feature branch, I can create some new commits and add on to this commit chain, which are only working on one specific feature instead of the whole development in general. So I can create some new commits that start implementing this new feature. And at the same time, maybe somebody else is working on the development branch, and they've created a commit on development. And so what happens is both of those commits point to the same parent commit. And so that's why they're called branches. So the branch up at the top is for feature, the branch down below is for development. And when it's ready to bring that feature into the same development code that everybody else is working on, and you want to see whether your code works with their code, what you would do is you would do a merge. So the command for it is git merge. And so I would go back to the development branch and merge in whatever changes have been made on the feature branch. So because they branched off, the merge is no longer as easy as moving from this place to that place. Now you have to create a new commit. And we can actually see that happen when we did our git pull, interestingly. So if we go back to our log, the very last commit up here is actually merge branch master of that repository with the master that I had, essentially, is what's going on there. So it did a merge, but you just didn't know about it. And I'm wondering, no, I think that's about it. Does that make sense?
That makes sense.
When do you use branch?
So you can create local branches to do pretty much anything. When you need to perform a new task and you're unsure of whether it's going to break other people's stuff or not, what you can do is you can create a new branch like feature, and say there were 20 more commits in this chain, right? You can keep merging the development branch into the feature branch whenever you want to test your code with other people's code, but you don't want to break what other people are doing. So you use branches to isolate the stuff that you're doing from what other people are doing, and it's really useful because you can create a branch that's incomplete code, right? So code that you know is broken, but you still want to back it up, and you still want to go back and look at old versions and stuff. And so that lets you commit more often, which is a really good thing. You want to commit as often as you possibly can because it lets you back up stuff as often as you possibly can. I'm pretty sure that makes sense.
And when merging some of these branches, does it sometimes fast forward?
Yeah, so a fast forward merge is what we saw up here. So I created, or say we had a master and a development branch, and we wanted to do a git merge. So we were on the development branch and we want to git merge master into where development is. So a fast forward merge just means you just move a pointer. The other kind of merge, like normal merging, is you have two different commits that point to the same place and you want to merge them together. So it creates one that points to the other two, as we saw there. So I went over quite a few commands today, and this doesn't even include that branching and merging sort of stuff. Cloning, adding files and committing files and that sort of thing. But I wouldn't bother trying to memorize the list of commands because everything that I'm talking about is online anyway. But I hope this lets you use that stuff online in a way that's more useful because now you know how Git works a little bit better, so you can use that stuff a little bit better. So the things that I do want you to take out of this is like knowing what the difference between Git and GitHub are. Because Git is a program on your computer which lets you do stuff with this repository. GitHub is a place where you can store the repository and it's a website with its own set of features. Knowing the difference between what committing is and what pushing is. So committing, like we saw, was just bundling up these changes and putting them in a filing cabinet on your computer. Pushing is taking that big filing cabinet or repository full of versions and putting it somewhere on the internet or on someone's computer or somewhere else on your computer, wherever it is. But pushing is copying it or uploading it from one place to another. And hopefully you've learned how to do those very basic things like how to pull, commit, and push in that workflow that we use in doing that. So for this project and these projects, there are a couple of things that I didn't go over which you probably need to know how to do, like cloning the development branch. So when you do your git clone to begin with, you need to make sure that you're on the right branch. I didn't go over how to do that. But also pulling often and committing often. So I showed you this graph right here, right, of this crazy chain. As you can imagine, this can get